This video is on factoring quadratics, specifically guess and check. Guess and check is used when you have three terms. So we're going to be dealing with what's called a quadratic trinomial. So we're using guess and check. This is the method we're using for three terms. And we have a vocabulary word called quadratic trinomial. So a quadratic trinomial is an expression of the form ax squared plus bx plus c. Trinomial. Tri means three, nomial means term. So we're dealing with three terms. We have one term here. This is called our quadratic term because this is an x squared. We have a linear term because this is bx. Then we have our constant term, which is our c. So please understand that the a value is going to be a number, the b is a number, and c is a number. X squared will stay as x squared. So a quadratic, because it has x squared in it, and that's your highest exponent, and then it's a trinomial because there are three terms. So in order to factor using guess and check, there are three steps to actually factor in it, and then you have helpful hints. So when we factor them, I'm just going to go over the explanation of how to use guess and check, and then I will do some examples of guess and check. So the first step, as for any factoring, is you take the GCF of the original. And I have said in an earlier video, you always wanted to factor out if your leading coefficient, your a value, was negative. You always want to factor out the GCF of a negative. So you always want to make sure, always make that a value positive. So you should, if you have a negative in the beginning, you want to make sure your GCF contains a negative with it. So that negative is brought outside of the parentheses. Okay. So once we get into, after we factor GCF, we'll have three terms left over inside the parentheses, and that's when we use guess and check. So our actual first step is GCF because that's normal. The step to guess is you take the factors of the ax squared term. So that entire first term inside the parentheses are actually the front terms inside the parentheses when you write out your two sets of parentheses. So just like when we did difference of squares, you had to take the square root of the a squared and then the square root of the b squared, and then the square root of a squared were the beginning terms of the parentheses, and the square root of b squared were the second terms of the parentheses. It's very similar to this. So we have to take the factors, so what multiplies to ax squared, and those will go into the beginning parts of our two parentheses. Factors of the c term, that's actually your last term, the c term, your constant, are the back terms inside your two sets of parentheses. So, for example, it might look like this. This is just an example, and it will not exactly look like this, but this is what I'm trying to show you. The factors of ax squared, so if I say like ax, because I know x times x gives me x squared, something gives me a, that'll be in the front. I'll have two sets of parentheses, so I'll have to have the other factor of ax squared in the front, just depending on what it is. Then the factors of c will be in the back of the parentheses, so I'll have to put my c's back here, whatever those factors are. Now, it obviously won't be the same number, so if this is a 7, I know a 7 and 7 won't go back here. It'll be maybe a 1 and a 7, because 1 times 7 gives me 7. So this is what we're guessing, okay? This is what we're guessing. We're guessing that these numbers are where they go. Now, to check to see if our guess was correct, we're actually going to multiply the outside numbers, and we're going to multiply the inside numbers. So what that means, so again, if we have our two sets of parentheses, the inside numbers, I'm going to say these ones first. These are the two inside numbers. So this C and that AX, these are the inside numbers. And then the outside numbers are the ones that are further away. So this AX and then this C, these are the outside numbers. You're actually going to multiply these two numbers, then you're going to multiply these two numbers. Now, these multiplications, those two multiplications that you just got, should combine. So they can either add together or they can subtract from each other, but they will combine to become the BX term. So we've used all three of the terms from up here: AX squared, BX, and C. So here's our AX squared, this is our BX, and this is our C. So all of the numbers will combine somehow to get our original. So some helpful hints that you will need to know is that when you are doing step 2, when you're trying to guess where the terms are going to go, where the factors go, no common factors should be inside the parentheses together. So as you're doing step 2, don't put common numbers together. Don't put common numbers together. So I have some examples down here of which ones are good and which ones are bad. So in this one we have a 2x and a 3. So the numbers 2 and 3, they have nothing in common. So there is no GCF to that. So this would be a good one. This is an okay factor. This next one, 3x minus 9, 3 and 9 can actually both be divided by 3. This is bad to be put together because you should have already factored the GCF, because that's what step 1 was. Basically what this is you never factor your GCF, and that's not good. So this is bad. Your factor should never look like that. X plus 1. This one is still good even though they share a 1. But remember, GCF of 1 does not affect the problem at all. So this is a good one. 4x plus 2. Both of these are actually even numbers, so automatically all even numbers can never go together. So you can't say that with odd numbers, because if this was a 5 and a 9, I could do that. But any even number is divisible by 2, so this should never happen. So this is also bad. Another helpful hint that you can follow is this is when you're doing your check, actually both your guess and your check. I didn't say anything about the signs of them being positive or negative, so I know I have to have some type of sign in between here, either positives or negatives or both or one of each. Somehow I have to have signs. So your signs are determined by the C term and then your BX term. So that's why we have to get our BX term as well. Okay. So if you determine if they're going to be the same or not the same. Your C term tells you if they'll be the same or not. If your C term, your constant term back here, is positive, if this is positive, then the signs are actually both going to be the same. So inside the parentheses, we'll have either both positives or both negatives. Your BX term will tell you what they will be. So again, you first determine will they be the same or not, then you can determine the rest of it. Okay, so if the C term is positive, they'll both be the same. Then the BX will tell you if the BX term is positive, they'll both be positive. If the BX term is negative, they'll both be negative. However, if your C term is negative, then the signs are different. So one of them will be positive, one of them will be negative. So this will go into step 3. When you find the correct terms that will combine to your BX term, if your BX term is supposed to be positive, then the bigger multiplication, so from step 3, the outside numbers or the inside, whichever one has the bigger multiplication, that one would have to be positive. If the BX term is positive, the bigger multiplication is positive. If the BX term is negative, then the bigger multiplication is negative. you can worry about the signs at the end, especially if C is negative. If C is negative, worry about the signs at the end. If C is positive, you can go ahead and put your signs in there because you know what they're going to be. They're both going to be the same, and then you know that they're either both going to be positive or both will be negative. But if C is negative, it's kind of hard to determine which set of parentheses will need the positive and which will need the negative. So you can deal with that at the very end of the problem. Now, if the groupings from step 2 and 3 do not work the first time, so if you try and put groupings together and they don't check out right, that does not mean the problem is wrong. That means that you just need to rearrange them. So you can rearrange, so your C's, like if this was 1 times 7, you could have your 7 here and then your 1 here, because that will change the multiplications. So you try them again. You're going to try all the combinations. A lot of times you'll just change around your C terms. So if your C terms don't work, and you've already rearranged them, you'll go up to the next factors that were possibly there. Because if you say, if we had the number 10, if C was 10, this could be a 1 and 10. It could also be a 2 and 5. But then we could also have a 10 and 1, and then a 5 and 2. So that's 4 combinations that you could have. But then you can have more combinations if your ax squared has multiple factors as well. So that can get very tedious and very time consuming. But once you get really good at determining your multiplications of them, it'll make a lot more sense, and the signs will also help you. But this part will help you as well because you know that you can't put even numbers together, and if they have anything in common, you know you don't want to put them together. So you're going to try all the combinations, but if none of them work, if not a single combination will work, then it cannot factor further. And the only thing that would work would be your GCF. And again, if your GCF is 1 and it cannot factor further, the answer is prime. If your GCF is anything except 1, then it's factorable. So we're going to do some examples of guess and check in a different video.